In this video, I'm going to go through a few questions and show you how to set up the application questions, or just refresh on how to set up application questions. Now, if you haven't already done so, I recommend printing off the PDF that I posted on the Google Classroom so that you can fill it in along the way. If you just want to listen, that's fine as well. So let's start with the first equation, or the first question. A test has 20 questions worth 100 points. The test consists of true-false questions worth 3 points each and multiple choice questions worth 11 points each. How many multiple choice questions are on the test? Your question is going to give you information about your let statements. How many multiple choice questions? That needs to be a variable. Okay? The fact that we have true and false and multiple choice, well, those are going to be my two equations, or my two let statements. So let X represent the number. Let's start with the true and false. The number of true-false questions. Let Y represent number of multiple choice questions. Okay, now we go back to the two statements we have, and each one should give us one of our equations. The easiest one is the total, which is I have 20 questions on this test. So if I add up the true and false and the multiple choice, that should give me 20. So I have X plus Y equals 20. The next information is going to be about the number of points. The test is worth 100 points in total. 3 points for each of the true and false, 11 points for each of the multiple choice. So if I take the number of true and false questions and I multiply them by their point value, so 3x, that's going to give me the number of points that are coming from true and false. If I multiply the number of multiple choice questions by their point value, so 11y, that's going to give me the total value, or the number of points that come from multiple choice. If I add these two together, so the 3x plus the 11y, I should have 100 in total. And that's it. From here, you can solve by substitution or elimination to solve for that x and the y. The x is going to give you the number of true and false, which we don't care about in this case, but the y variable, whatever you get, will be the number of multiple choice questions. So look at your question for the let statements, and then read the other 2, 3, however many sentences to pick out where each equation is going to come from. Okay, the next type of question we're going to look at is coins. Okay, which you saw in grade 9, so it should be a little bit more familiar. Lynn has $3.55 in dimes and quarters. If there are 25 coins altogether, how many of each coin does she have? How many of each coin does she have? So let D represent number of dimes, let Q represent number of quarters, because that is what the question is asking me for. And notice, I'm not just saying let D represent dimes. I'm saying let D represent the number of dimes. Let Q represent number of quarters. Okay, and from here, let's look for that easy total information. There are 25 coins in total, so if I add up the number of dimes with the number of quarters, I should get 25. Now the next equation is going to come from the value. I have $3.55 in total. I know dimes are worth 10 cents, which in dollars is 0.10, and quarters are worth 25 cents, which is 0.25. Now if I multiply each value by the number of dimes, the number of quarters, and add that up, I will get my total. So dimes are worth 0.10. So when I multiply that, I get the value, the dollar value of all the dimes. And when I multiply 0.25 by the number of quarters, Q, I'm going to get the total dollar value of quarters. And together, that's going to be $3.55. Do not multiply this 355 by 25. I've seen that before. That doesn't make sense because not each coin is worth $3.55. $3.55 is the total value of all of your coins, or all of Lynn's coins. And again, from here you can continue solving with whatever method you prefer. Some people here might also convert all the dollars to cents. So 10D plus 25Q equals 355 is also a good enough equation that you can use. Okay, number 3 is investment. Okay. Isabel invested $8,000, part in a 9% per annum account and the remainder at 4% per annum. After 1 year, the total interest from these investments was $420. How much did she invest at each rate? So how many dollars were put into the 9%? How many dollars were put into the 4%? So there are the let statements. Let X represent money or dollars at 9%. Let Y represent money at 4%. So what was put into each account? Together, if I add up what was put in the 9% with the 4%, I should get $8,000 because that's what this statement tells us. Isabel invested $8,000. Now, the next statement or the next equation is going to come from the 420. That's how much the bank is giving her. So, the bank's going to give you 9% of how much you invest at 9% and 4% of the leftover. And when you add that up, you're going to get 420. So if I want 9% of what was invested, when you take a percentage of a number, we have to turn that into a decimal. So 0.09 of X dollars plus 0.04 of Y dollars is going to give me the total that the bank gives you back at the end of the year. Okay, so I'm just taking 9% of X dollars plus 4% of the Y dollars that she invested, and that's going to give me my total interest. And that's it. From here, I would use substitution, personally. But you could do elimination, totally fine. Okay, now we're on to 2 different mixture problems. I put a money mixture, like a bulk barn type of thing, and a concentration solution type of thing. So we have 2 different kinds of coffee beans were blended. One coffee cost $2.30 per kilogram, and the other cost $3.20 per kilogram. How much of each kind was used if we have 200 kilograms of the resulting mixture, and it costs $3 per kilogram? The question, how much of each kind was used? Okay, so let X represent kilograms of type 1. Let Y represent kilograms of type 2. Okay, what's our easy equation? Well, the total mass is 200. So if I put X kilograms of the first type, Y kilograms of the second type, in total, I'm going to have 200. So there's our nice, easy X plus Y equals 200. The next is going to use the cost. Okay, so let's circle what's important here. Coffee 1 is $2.30 per kilogram. Coffee 2 is $3.20 per kilogram. And the mixture is going to cost $3. And that's for 200 kilograms. Okay, so the first one's 230. So when I multiply $2.30 by the number of kilograms of type 1, this is going to give me total cost of coffee 1. Okay, now if I do the same thing for the second type, that's $3.20 times the number of kilograms. Okay, so each kilogram is 320. I have Y kilograms. When I multiply it, that's going to give me the total cost of coffee 2. When I add that up, that's going to give me the total cost of the entire mixture. That is not just $3. Okay, it's $3 for every kilogram, and there are 200 kilograms in total. Okay, so we have to multiply 3 by 200 to get total cost of mixture. Okay, now over here, I would simplify this equation. I wouldn't call this equation number 2. So usually you'd say, okay, here's equation 1, equation 2 for me. I'm just going to simplify that multiplication. So 2.30x plus 3.20y equals 600. And those are the two equations. I would ignore that middle one. That was just a little sub-step. Okay, now this is the same layout that we're going to use for the next one with the concentration. Okay, but now instead of a price, it's going to be a percentage of milliliters. Just like in the group questions today. So we have a 60% sulfuric acid solution will be mixed with a 95% sulfuric acid solution to produce 2,700 milliliters of a 70% solution. How much of each concentration is required? So do not tell me let X represent 60%, let Y represent 95%. You have to be more descriptive. I want to know how much, the quantity or the volume. So you can say let X represent milliliters of 60%, let Y represent milliliters of 95%. Okay? These X and Y variables represent a volume, milliliters. So how many milliliters am I going to have in total? 2,700. So here's our first basic equation. The next one is going to come from the concentrations. I have 60% sulfuric and 95% sulfuric, and that's going to give me a total mixture that's 70% of that volume. So I'm going to take 0.6, because that's 60%, times X. This is going to represent the pure sulfuric acid. So I'm taking 60% of my volume. So this is going to represent milliliters of pure, I'm just going to call it SA, sulfuric acid from the 60% solution. Okay. Then my second one is 0.95, so 95% of Y milliliters. This is going to represent the milliliters of pure sulfuric acid from the 95% solution. When I add that up, that should give me the number of milliliters of pure sulfuric acid from the mixture. My mixture has to be 70%. So I need to figure out what's 70% of the total volume. And that's going to give me the pure sulfuric acid. Okay, the pure concentrate. Okay. And again, I would not label this equation 2. I would plug that into my calculator and simplify it. I don't have a calculator on me, so for now I'm just going to leave it like this. But just remember, for these bulk barn and these concentration questions with acid or whatever, make sure you're paying attention to that second equation. If I'm multiplying concentration by volume here and concentration by volume here, then my total better be the same thing. Concentration times volume, or the units will not make sense. Okay, last questions, distance, speed, and time. Let's start with one of those with the wind, against the wind type of questions. A plane flew 3,000 kilometers from Calgary to Montreal with the wind in 5 hours. The return flight into the wind took 6 hours. Find the wind speed and the speed of the plane in still air. Okay, there are my two let statements. Let X represent speed, I'm going to start with the plane, of plane. Let Y represent speed of wind. Okay. So I know I'm going to have one with the wind and against the wind. Remember, when you're going with the wind, when I add up the two speeds, it should be a faster one. And when you're going against, you're going to subtract the speeds because you're getting slowed down. So let's do that side calculation. With wind. We know that the speed is equal to the distance divided by the time. And that's in your in your triangle right over here. Speed, distance over time. So we're going to use that. The total distance is 3,000. Okay, and it took 5 hours. So the speed with the wind is going to be 600 kilometers per hour. And there's our first equation. X plus y equals 600. Now, when we're against the wind, okay, we're still traveling the same distance of 3,000, but now it's taking us longer. It's taking us 6 hours. So when we do that, you get 500 kilometers per hour. So your second equation is going to be x minus y equals 500. And that's it. With the wind, the speed is enhanced, so we want to add the wind speed and the speed of the plane in still air. When we're going against the wind or into the wind, we want to subtract it because we're getting slowed down by that wind. It's pushing us back. Now that's the more basic one. Now I want to go to the one that you have to do a few more modifications. So when you're traveling at two different speeds in a trip. Joseph drove 500 kilometers from Windsor to Peterborough in 5.5 hours. He drove part of the way at 100 kilometers per hour and the rest of the way at 80 kilometers per hour. How long did he travel at each speed? I did change the question. Now, we're asked about the time. Okay, how long did he travel at each speed? So we're going to have, okay, well, let x represent hours at 100 kilometers per hour. So the number of hours he spent at this speed. And let y represent hours at 80 kilometers per hour. Now these variables represent hours, the length of time. I know the total length of time. It's 5.5. So my first basic equation is going to be x plus y equals 5.5. Now, the other statement or the other equation is going to come from this 500 kilometers total that was driven. Now, that's a distance. So we have to go to our triangle here. And if we look, we see distance is equal to speed times the time. So I need to figure out what distance did he travel at 100 kilometers per hour and what distance did he travel at 80 kilometers per hour. So let's start with that first portion. The speed is 100 kilometers per hour and the time is x. We don't know it. So if I multiply 100 by x, that's going to give me distance of first part. So that's how much he traveled in that first portion. Then he changed his speed and he started driving 80 kilometers per hour. The speed is 80. The time is y. It's a variable and that's fine. This is going to represent the distance of the second part. Now if we add up these two distances, it's going to give us the entire trip, which was 500 kilometers. And that's it. This is total distance. And then you can solve in whatever way you choose. Just remember this distance, speed, time triangle. So that's it for the different types of application questions. Hopefully this was helpful and you can use this as a reference when you're studying and when you're trying to set up the equations. But once you get in the habit and you do enough questions, they start to look familiar and things just click a little more. So I really hope this helped.